All right, I'm gonna do part of this super duper late for old folks, so I'm only gonna do a little bit of this, and then I'll make another video for the rest. So you are gonna have to hustle your butt through some of these earlier things, or the ones that pop up throughout the test that should be pretty straightforward. Rewriting between log and exponential means you can say, hey, this is log base b of some number equals the power, and I can get that back and forth to base to this power equals this answer. You want to be able to go back and forth between those two forms. So in this first one, base over here, get the power, come around. I'm not solving, I'm simply rewriting. So 5 to the x equals 625. So my fear on the test is you're going to get caught up and do more than you're being asked to do and run out of time. So really pay attention to the verbs. Same thing here. This is ln, which implies base e. If it helps you to write it and see it physically, then do that. So I end up with e to the x equals 7. Here, 4 is my base. Over here alone would be x as a power. So 4 to x equals 1 over 64. Keeping in mind, if I was solving that, I'd have to use a negative power to get it to go into the bottom. My verb is still rewrite, and so I'm going to go ahead and do that. So 3 is the base, so I would write log base 3. The power always stands alone, so the 81 fits in here, even though it looks like an 8. Log, and here the bottom thing raised to a power is the 4. And then the power always goes over here, so my 256 crams in here. I always wonder how other people can write neatly. I wish I could. This is base 10, and when you are base 10, that's the common log, and so you actually don't write it. So I'm just going to write log implied base 10. The power always goes over here, so the 10,000 gets crowded in there. It's not asking me to evaluate. I'm just checking to make sure that it does that later, because that is something you have to do on the test, and I see that it does. Next, we're going to solve. This says without a calculator. That's not a thing on the test. So we did that on part of the quiz. And so we're going to just go ahead and use your calculator if needed. This, you want to sort through the 4 types. This has logs on both sides, so I can cancel them out. Pretty darn easy. X is going to equal 15. With log equations, you do need to check for extraneous solutions. But in that case, 15 is not causing a problem, which would mean forcing me to take the forcing me to take the log of a negative, but plugging a 15 won't. Okay, this is a log problem with logs on one side. The key to unlocking these is to rewrite it as a power expression or an exponential. And then you should be able to like noodle your way through that. 6 to what power? 6 has to be a 1. So like this is what I'm talking about in terms of length. These problems have to be something you can feel confident going through pretty quickly. So this is saying 3 to the x equals 3 to the 9th. Well, the only way that's true is if x has the value of 9. And this one doesn't show a base, so it implies base 10. And it's asking 10 to what power is 1. And the only way that you can get a 1 out of that would be if the power was to be 0. All right. This is an ln question, but this is ln base e. So you can think of it a couple different ways. This is saying e to what power equals e to the 8th. That's probably the easiest way to do it. And so we'll stick with that. And the only way that's going to be true is if my x value is 8. Here, this is that whole chop thing where if you have a base and then you have a power of the same base in its, like up in the power there, this part cancels, leaving you with just whatever is left. So in this equation, because this is e to the ln, which is base e, that part cancels, and then 19 is the only thing that remains. So I end up with 19 equaling x. Okay, here, this is ln, so it implies an invisible base e. And so the question is e to what power equals 1 over e to the 5? Well, the only way that goes into the bottom is to be negative. And the only way it becomes fifth power is if you have a 5. So x equals negative 5. Here I have logs on both sides. I just kind of check, like, is there only one on each? Yes, log. They're always going to be the same base, so I can cancel those out. And then this becomes a pretty straightforward question. So I get a value of 10. Plugging a 10 in there, 10 minus 4 is a positive number. So that's going to be a viable solution for that. If it forced me to take the log of a negative, then it wouldn't be. All right, this verb is expand. So I need to know these properties, and this gets tested in a variety of ways. So really think through what you're doing and why. All right, so here, first thing I have is this square. The rules of power say that would distribute to both. So you can think of this as the log of x squared over y squared. And those are put together by division, so I separate them through subtraction. And when I'm expanding, I have to drop everything down in front. I can't have powers. So then my answer is going to be 2 log x. I'm just checking the base. They both were base 10 minus 2 log y. Messy too, but whatevs. This is a little confusing, but you can think of this a couple different ways. This square root is going to be a 1/2 power. So I guess one way you can think of that is to say that would be x, y to the 3, but then also times to the 1/2 power, because 1/2 power is the same as square root. So it becomes the natural log of x, y to the 3/2 power when you multiply the two powers. So when I drop that 3/2, well, I can drop it down in front. There's two ways to do this, so I'm like working my way through which way is probably better. I would probably move this down in front, and then that's going to be in front of ln x times y. And then those separate by addition because they're together with multiplication. And then I can go over here. If you have to write the answer, I would take this as an answer if you'd like. I also, personally, I would probably distribute it. So I would have this and this because you're trying to expand it, and that makes it as expanded or big as possible. The other way is not wrong. What am I doing here? Expanding this. There's not really a lot of expansion I can do. Like nothing separates because I just have that x to the 8th, except drop the power. So I end up with 8 out in front of log x. And sometimes it just is that easy, so don't freak yourself out. Here I have two things that are multiplied together. So I'm going to separate my x cubed and then the ln of h squared through addition. And I'm going to drop each power down in front. So that would be 3 ln x plus 2 ln h. Here I have an x and a y and a z. The x and y are on the top. The z is on the bottom. So when I separate them out, I'm going to have x is positive, so that's why it was on top, plus ln y because that was on top, but the z is on the bottom, so that becomes a negative or a subtraction. So I have, one of the things that I would appreciate you doing is if there's answer lines like this, please write your answers on there. Because if I'm going through over 100 tests and I'm trying to look back and forth to find your answer in your work, it gets to be really tricky and time consuming. Then I get crabby, and nobody wants a crabby teacher while they're grading your tests. So here, these will separate by addition, and I'll have a log base A of each of them. And then that's it. So again, don't, wait, what did I do? I did a stupid thing here. This should be log base A again of y, and then log base A of z. Never start your math at midnight. That's what I'm learning. So I'm really glad I wrote that over there so that I can come over here and write it. If it's a simple one like that, just go ahead and put your answer right onto that answer line. You're not going to need to have work shown unless it's solving and says show your work. Ooh, this one looks like a doozy. The 1/4 applies to everything. So I would probably drop it down in front. And that's going to leave me with the log base b of this mess. But I'm actually going to also change this to a 1/2 power because that's what it means. So these are separated, or I should say put together by division. So I'm going to have a 1/4 out in front because of that dropped power. Then I'm going to have log base b of this top part minus, because they were separated by division, log base b of y to the 4th. Okay, but that's going to drop the 1/2 down in front and the 4 down in front. So now I'd have 1/4 in front of 1/2 log base b of x plus 2, and then minus 4, because I'm dropping that power, log base b of y. But I'm going to distribute this 1/4. So when I go to write my answer on the world's smallest answer line, I'm going to have 1/8 log of x plus 2. That's just the log of one thing because that's a clump of stuff in a parenthesis. And then minus 1/4 times 4 right here would turn into 1. So the coefficient goes away. And so I end up with log base b. Okay, that looks like a y. Log base b, so messy. Why can't I write neatly? Log base b of y. Plus I get all freaked out when I get to the edge. I have Miss Arnold's answer key laying on my counter, and I'm seeing that she has that second part wrong, that the 1/4, because it affects everything here, should also affect this 4. So on her answer key, she has a 4 with the log base b of y, but it shouldn't be there if you're looking at the online key. Okay, then here, this 3 also affects everything because of the power, parentheses. So I drop it in front and have 3 ln of a to the 4, b to the 2nd. Then I'm going to split those up into ln a to the 4 plus ln b to the 2nd. Then I'm going to drop my power and have a 3 out in front of 4 ln a plus 2 ln b. Distributing my 3, I get 12 ln a plus 6 ln b. Let's see. How far am I going before I go to bed? Because it's midnight. Evaluate the following with your calculator. Oh, totally can do that. Now, if you have an old gal calculator like me, you're going to have to go back to that change of base concept, and you'll put in the log of 19, shut her down, and then divide by the log of 5. It's super easy to remember that the base goes on the bottom because the base goes on the bottom, down below. And so on your calculator, you're typing in log 19, close your parenthesis, divided by log 5. Unless you're able to go to your math key and scoot down and find yourself a thing that says log base, which will let you type it in. Now, I'm going to actually pay attention to this, knowing that if it says it, I should do it. Round to 3 decimal places when necessary. Well, it's necessary. Here I'm getting 1.8294, so it'll stay as a 9. Here I'm going to go ahead and just do that math. I'm going to go ahead and find my log base. I have it on this calculator at home. So when I do this problem, I'm getting, because this is asking 8 to what power is 6, who knows? But what I'm getting on my calculator is 0.8616, but 0.8616, when it says round to the nearest 3 decimals, means that this would have to be 0.863. 2. So do what it says. Make sure you round to 3 if it says so. ln 22, I just typed that into my calculator, 3.091. Same thing here. I can either use my log base if I've got it, or I can do the log of 93 and divide it by the log of 7. And this one's 2.3292. And so to do 3 decimal places, the 2 is not going to change the 9. So be careful. Condense. Oh, I can do these before I have to fall asleep. Also, I'm going to stop here and after this thing. And then I'll pick up and do another video for you tomorrow. But this will at least be a start. So the first thing to condensing, pay attention to your verbs, is to move those powers up and out of the way. So you can't do log stuff until you just have logs. You can't have other stuff in front. So they're separated by subtraction. So when I write them together, I'll have log written one time with my x squared over y to the 9th. If you want to have parentheses, you can. You don't need to. Here, I got to move all of these powers out of the way. So I have ln x to the 6th, ln t to the 5th, minus ln r to the 4th. So when I go to put those together, I'm going to have ln written one time. And you're condensing, you should only have the log or ln written one time. The x to the 6th and the t to the 5th are positive terms. They're plus. But the r to the 4th follows the subtraction sign, so that goes on to the bottom. In this next one, I am going to move these things. I'm going to do what's inside the parentheses first. So I'm just going to let this hang out for a little bit. This is ln f minus ln m to the 9, and then plus ln g to the 6. Okay, so then I'm going to I'm trying to decide if I'm going to distribute. What you ultimately are doing is, yes, you're distributing this, but it's going to put a 1/3 in front of each thing. And since I'm condensing, I can't have numbers in front. So I'm going to end up, like if my next move was 1/3 ln f, I'd have to move it up. Minus 1/3 ln m to the 9, I'd have to move it up. So let's just go straight to putting it up into the power. So this 1/3 would scoot up into the power of f, and I'd have ln f to the 1/3. Here, though, I'm going to have minus ln m to the 1/3 times 9, so that becomes a cube. And then in the third term, I'm going to have that 1/3 coming up into the 6th power. So I'd have 1/3 of 6. So I end up with ln of g squared. And I'm condensing, so I'm going to go ahead and put those together. So this is going to be ln written once. I would have f to the 1/3 on the top because that's a positive term. But this second term minus ln m cubed means the m cubed goes on the bottom. But then my next term follows a plus sign, so my g to the 2nd goes on the top. But I don't write a 1/3 power in my answer. So which one am I on? D, because I didn't copy my answer for C. Oh, I totally skipped it. I wrote over it, so I have to go back. So my 60 answer is going to have ln, and then this is going to be a cube root of f. Excuse me. And then this is going to be over m to the 3rd. Here, I'm going to scoot that up and have log x plus log p to the 8. They are separated by adding, so I'm going to put them together by multiplication. So I skipped an easy one. Okay. This next one looks tricky. I'm gonna just switch colors so I can keep myself organized because I made such a mess of the last thing in blue. So, all right, this has to go and this has to go before I can truly condense. So I have log A of y plus 2. And then I have log base A of x minus 1 cubed. And then I have minus log base A of s to the 4. So now I can put them together, and I'm going to have log base A, the y plus 2, and the x minus 1 cubed all go on the top because they are positive terms, but this follows a negative, so just the s to the 4 goes on the bottom. And I am not going to make you multiply x minus 1 times itself 3 times and then multiply that by y plus 2, so you can just leave that. And now I'm getting to my favorite verb in math, and that is solve. I'm going to go ahead and finish these. I'm going to regret that. I better stop. It's 12:15. All right, I'm going to quit. We got through, so this looks like so much work, but it hasn't been a lot of work. I mean, you guys wouldn't do all the work on these and explaining as you go. So you do have to be efficient with these things that say rewrite, convert, expand, condense, solve. You want to be pretty good at those. And by pretty good, I mean really awesome. So you can just cruise along, beep, boop, bop. Some of them will be matching, some will be multiple choice, some will be working through the problems. So just be able to cruise through those so that when you get to the solving, and then later you get to the graphing, and then later you get to the regression, on those you can slow your roll and work a little bit more. So I'll stop here, and then I'll pick up where I left off and do another video for you at a different time. Thanks, guys. Bye.